Look up at the night sky. What do you see? A vast expanse, seemingly endless, dotted with countless points of light. Each one of those points is a star, a distant sun, burning brightly across the cosmos. The night sky is a window into the universe, a glimpse into the infinite, a canvas of twinkling stars. These stars, though they appear as mere specks from our vantage point, are colossal furnaces of nuclear fusion, each one a powerhouse of energy and light. They twinkle and shimmer, their light traveling vast distances to reach our eyes. Each a distant sun, a fiery furnace burning across the vastness of space. Our own sun, a relatively average star, is a testament to the incredible power these celestial bodies hold. Imagine the energy, the heat, the sheer force of a star much larger, much younger, or much older than our own. Their light, a messenger from the past, whispers tales of cosmic wonders. The light we see from these stars has traveled for millions, sometimes billions of years to reach us. It carries with it stories of the universe's history, of events that occurred long before our planet even existed. We, bound to Earth, can only imagine the raw power these celestial bodies possess. From our small blue planet, we gaze up in wonder, trying to comprehend the scale and the majesty of the universe. The stars are both a source of inspiration and a reminder of our place in the cosmos. But what if we could experience it firsthand? What if we could leave the confines of our planet and journey to one of these distant suns? The idea of traveling to a star is both thrilling and daunting, a dream that has captured the imagination of humanity for generations. What if we could journey to a star, not as distant observers but as participants in its fiery ballet? To witness the birth, life, and death of a star up close would be an experience beyond anything we can currently imagine. It would be a journey into the heart of creation itself. This isn't a journey for the faint of heart. The cosmos is a harsh and unforgiving place full of dangers and challenges that we can barely comprehend. The intense radiation, the extreme temperatures, the vast distances, all of these factors make space travel incredibly difficult and perilous. The cosmos, for all its beauty, is unforgiving. And our destination? A star unlike our own sun, a youthful inferno known as a Herbig Ae. These young stars are still in the process of forming, their intense heat and energy a testament to the raw power of the universe. A star unlike our own sun, a youthful inferno known as a Herbig Ae. These stars are surrounded by clouds of gas and dust, the building blocks of future planets and solar systems. To journey to such a star would be to witness the very beginnings of a new cosmic dance, a dance of light and heat that has been ongoing for billions of years. Stars like us have a life cycle. They are born, they evolve, and they eventually die. This cosmic journey is a fascinating process that spans millions to billions of years, depending on the mass and type of the star. From the quiet birth in a stellar nursery to the dramatic end as a supernova or a quiet fade into a white dwarf, each stage of a star's life is a testament to the dynamic nature of our universe. Herbig Ae stars represent a star in its rebellious teenage years. These stars are relatively young, typically only a few million years old, and are still in the process of contracting and heating up. Still shrouded in the dusty cocoon of its stellar nursery, a Herbig Ae star is a hot, massive star in the making. These stars are often found in regions rich with gas and dust, the raw materials from which they were born. A Herbig Ae star is a hot, massive star in the making. Unlike our middle-aged sun, content with its hydrogen fusion, these young stars are still in the throes of their formation, burning brightly and erratically. Unlike our middle-aged sun, content with its hydrogen fusion, these young stars pulsate with an erratic energy. Their surfaces are turbulent, with intense magnetic activity and frequent flares. These young stars pulsate with an erratic energy. Their brightness can vary dramatically over short periods, a sign of the intense processes occurring within them. They are surrounded by disks of gas and dust, the remnants of their formation from which planets may eventually form. These protoplanetary disks are the birthplaces of future solar systems. The remnants of their formation, these disks are rich with the building blocks of planets. Over time, these materials can coalesce to form planets, moons, and other celestial bodies, from which planets may eventually form. This process can take millions of years, but it is the same process that formed our own solar system. Their energy output dwarfs our sun's. They emit intense radiation, a blistering mix of ultraviolet and X-rays. This radiation can have profound effects on the surrounding environment, influencing the formation of planets and the chemistry of the surrounding gas and dust. a blistering mix of ultraviolet and X-rays. This intense radiation can strip away the atmospheres of nearby planets, making the environment around a Herbig Ae star a harsh place for any potential life. Approaching a Herbig Ae star would be like stepping into a cosmic blast furnace. The intense heat and radiation make these stars some of the most dynamic and fascinating objects in the universe. Imagine the hottest desert you can. Multiply that heat 1,000-fold. Now add intense radiation, enough to fry any unshielded electronic device in an instant. That's the kind of environment we're talking about. The surface temperature of a Herbig Ae star can reach a scorching 10,000 degrees Celsius. No life as we know it could exist in such a place. But the heat is only the beginning. Herbig Ae stars are also notorious for their stellar winds. These are streams of charged particles ejected from the star at incredible speeds. They'd rip through a spacecraft like a hot knife through butter. Our journey, it's becoming clear, is a one-way trip. Let's assume, for the sake of this thought experiment, that we have a spacecraft capable of withstanding these extreme conditions. What would it be like to fall into a Herbig Ae star? Initially, you'd be blinded by the light. Herbig Ae stars, even from a distance, shine with an intense blue-white light, far brighter than our sun. As you drew closer, the heat would become unbearable. Your spacesuit, no matter how advanced, would begin to fail. The radiation would penetrate your body, disrupting your cells and DNA. Death, in this scenario, is a certainty, but how would it unfold? The human eye wasn't designed to withstand the fury of a star. As you fell towards the Herbig Ae, your vision would be the first to go. The intense light would overwhelm your retinas, leaving you blind, but it wouldn't be darkness you'd experience. Instead, you'd likely see flashes of light, hallucinations caused by the dying screams of your optic nerves. The heat by now would be agonizing. Your skin, your organs would feel like they were burning from the inside out. You'd be alive, but only barely, your consciousness fading in and out as your body succumbed to the inevitable. Here's where things get really interesting, from a purely scientific perspective. The human body is held together by chemical bonds. These bonds are strong, but they are no match for the intense heat and radiation of a star. As you fell deeper into the Herbig Ae, these bonds would begin to break down. Your body, once a cohesive whole, would start to disintegrate. First, your skin and muscles, then your organs, and finally, even your bones would begin to vaporize. You wouldn't explode, not in the traditional sense. You'd simply cease to be, your atoms scattered into the stellar wind, becoming part of the star's raw material. If there were any part of this journey more terrifying than the disintegration, it would be the spaghettification. Gravity, as we know, is a powerful force, and the gravity of a Herbig Ae star is immense. As you fell towards the star's core, the difference in gravitational pull between your head and your feet would become extreme. Imagine being stretched, like a piece of spaghetti, thinner and thinner. That's spaghettification. Your body, already ravaged by heat and radiation, would be pulled apart, atom by atom, until there was nothing left. The death would be instant and painless. Imagine, in the vast expanse of the cosmos, a supernova erupts with unimaginable force. The energy released is beyond comprehension, obliterating everything in its path. Yet for any being caught in this cosmic event, the end would come so swiftly that there would be no time to even register the pain. There would be no time for pain receptors to fire, no moment of agony. The sheer speed of the event would outpace the nervous system's ability to respond. In the blink of an eye, existence would be snuffed out, leaving behind only the serene beauty of the starry sky. No time for your brain to process what was happening. The mind, with all its complexities and thoughts, would be rendered obsolete in an instant. One moment, you are a conscious being, aware of your surroundings, and the next, you are part of the cosmic tapestry, your essence scattered across the universe. One moment you'd be there, falling into the star, feeling the pull of its immense gravity. The sensation might be overwhelming, a mix of awe and terror, but before you could fully grasp the magnitude of the experience, you'd be gone. The next moment you'd be gone. Not with a bang, but with a whisper, your presence in the universe would be erased. The light that once shone brightly would flicker out, leaving behind only memories and stardust. Not with a bang, but with a whisper, your atoms dispersed into the stellar sea. The universe in its infinite wisdom would reclaim what was once yours, scattering your essence across the cosmos. Your atoms dispersed into the stellar sea. These atoms, the fundamental building blocks of life, would drift through the vastness of space, becoming part of the cosmic dance. But here's the thing about atoms. They're the building blocks of everything. Every star, every planet, every living being is made up of these tiny particles. They are the universe's way of recycling and renewing itself. The atoms that once made up your body, the very essence of your being, would not be lost. Instead, they would find new purpose, new forms. They might become part of a distant star, shining brightly in the night sky. Forged in the heart of a long-dead star, these atoms have traveled across the universe, witnessing the birth and death of countless celestial bodies. They carry with them the history of the cosmos, a testament to the cycle of creation and destruction. Would be recycled into the Herbig Ae. This process of cosmic recycling ensures that nothing is ever truly lost. The universe is constantly evolving, constantly renewing itself. Perhaps they'd become part of a planet, or maybe another star. The possibilities are endless. Each atom has the potential to become something new, something extraordinary. The universe is a beautiful, chaotic dance of creation and destruction. It is a reminder that even in the face of obliteration, there is always the promise of new beginnings. The cosmos, in all its vastness, is a testament to the enduring cycle of life, death, and rebirth. So, there you have it, a journey to the heart of a Herbig Ae star. Not a trip I'd recommend, but certainly a thought-provoking one. It reminds us of the raw power of the universe, the incredible forces at play in the cosmos. It also highlights our own fragility, the fleeting nature of our existence in the grand scheme of things. But it shouldn't make us afraid. Instead, let it inspire us. Let it remind us to cherish our time on this pale blue dot, to explore, to learn, and to marvel at the wonders of the universe we inhabit. For even in death and destruction there is a strange, awe-inspiring beauty.